Hey guys, this is Ayush back with another video guide. So today I'm going to be, I know that a lot of us, or some of us were finding the recursion tricky because, uh, like, it's like something kind of different than the usual iterative algorithm, which I actually agree with. It is kind of tricky at first. And so I decided that I'll make a video guide about that. And so this will be for using the debugger to really understand everything going on with recursion. So, okay, what this function does is this is a recursive function, calls itself twice, and I want to find out if we pass in the value of 5 and one of the iterations just subtracts from 5 and one of them adds from 5, will it reach 1 first or will it reach 10 first? That's what I want to know. And so yeah, also like basically it will put the value of a into an empty vector, and then like whenever it reaches one of these, it will put the whatever value it is into an empty vector, and then it will insert that vector into here. I know that there's some unnecessary like stuff going on here, but I just wanted to like increase the complication a little bit, just to show like kind of be comfortable with debugging a little bit more complicated syntax. So what I would do is I would just, to understand what's going on, first of all, let me just show you what happens when it runs. Or I'll just explain it. So when it runs, it comes into an error, like it just says process code finished with exit code negative something, and it can't really print anything. And I'll explain why in a second. So I have this function fine, but it's not. And if I debug it, all I have to do is like check the value of a, which is the one that I'm kind of modifying with every iteration. And let's just step through this. So it starts at 5, goes to 4, and then keeps on going down, and finally a is 1, and then that works properly. We are pushing that back into the vector c. So then, and then if we look at c and then we look at d, these vectors are actually the same at this point, which means that like I could even show you like c dot at 0 and whatever, and it will show you that they're the same. So they're being inserted fine, but it's still, even though that part's going well, it's still not working the way I want. Also, I must mention, by the way, that this part I put up here, this if statement that covers the whole everything inside the function, what that does is it's that, like, basically if a goes -1 like to infinity, just keeps on subtracting, and that causes an error. That's the if statements to protect us from that happening. So we're just going to stay in bounds, and then what it does is that each time the recursive function calls itself, it'll look into this if statement, and if a is not in the if statement, it'll just continue to the end and not follow any of this code. And if it does that, then it won't be calling itself again, so it will automatically just end that branch of the recursion. So yeah, just end that. Okay, so anyway, let's continue with this. So if I look at it, watch it go, you'll see that a was 1, now it's increasing. It went to 3, then it went to 2, and it went to 1, and then you'll see that I think if I did this for long enough, you would see that a does not stop at -20. It instead goes to like -19, and then from there it actually goes up to -18, -17. So it just keeps on going back and forth infinitely, and so that's how you would figure that out with the debugger. Like, you can just easily watch and keep on stepping through. And yeah, I would strongly recommend using the debugger because it makes it super easy to understand. Not easy, but like super possible to understand the recursion and everything going on. Um, so let's see. Okay, so yeah, I told you about using the debugger and figuring out everything that's going on by just stepping through simply and making sure it's the way you want. But let's say I want to solve this specific problem, then it's really easy. There are many ways. One is that I prefer is I'm creating a boolean called done. It's a boolean called done, and it's accessed by reference, and it will become true the first time a is at the desired endpoint. And so, watch this. So even if I already have all that done, or it's setting done to true, um, that we're not finished there yet because we also need to include. So what this does is that as the recursion goes on, if done is false, it'll basically only call itself again if done is false. So once it actually like finishes and does this and then done becomes true, then it will not continue infinitely longer back and forth because now we're gonna know that bool done is false, so we're not gonna call ourselves again. And also know that we're accessing this by reference, which means it's accessible to like all branches of the recursion. So if we set bool done when we're like literally at like this node of the recursion, then the program's gonna know that it's done at this level and at this level. So like I think the program runs all these branches like at the same time. I'm not 100% sure, but let's just pretend like it only runs each one like one at a time. So like for this branch, we set bool done equals true right here. Then then it will actually not run down this branch because if we're gonna know that bool was done even up at this level. So if I could explain more clearly, let me think about that. So I guess like another way to say it is that we're starting at a is 5, so we're calling, what I showed you was like maybe how it would traverse down the branch of a becomes 4, and then everything that can happen from there. But then there's also another possible branch that if a becomes 6, and then you can traverse down that branch. But now, because we're at a really specific node of the whole recursive um, functionality or setting done to true, it will actually know that done is true up at like a higher node. Well, and you'll know that for branches that it hasn't even traveled down yet, it will already know that bool is done up at those higher levels. So it will not travel down the extra node. I mean the extra this other branch because it was set to hopefully that made sense. There's a bit of complexity that comes into your understanding of recursion once you start debugging it, but I would strongly recommend using the debugger for this because everything I know about recursion is from the debugger. Debugger is like really practical for this. Anyway, so if I now that I put that fixation, let's stop the debugger and let's actually run this. print out one space one, and that's what it's supposed to do because b is a vector that's originally set to one. It finds that we reach one first, so we add we append one to vector b, and then also note that then even so after we do that, then it won't ever traverse down any of these recursive calls again, and when the function calls itself and it doesn't do anything during that call, that's when a branch ends, like